Hey Damini, hi, Rahul here. Please make me the presenter.
Done, Rahul.
Okay, thank you. So guys, we'll start in another 2 minutes. Let me see if everyone is there. Yeah, I'll wait for some time. Yeah. Meanwhile, the agenda for the day will be to first talk about the ADA boost. If anyone have any doubts, uh, then we will implement the model, and then to go through the gradient boosting model, like how the gradient boosting model works, similar to the ADA boost. Okay, so that's what we are going to discuss, and then we will implement both of these models, and then we'll take a quick break, and we will not go into the XG boost and cat boost today, because I don't want to tell you all the models in one day. It will be confusing. So we will start with the the basics of time series modeling in the second half of the day, uh, and then tomorrow we will again start with the light boost or the cat boost models. So we will today talk about the GBM model for regression and GBM model for classification, how it works, and then we will start with time series, if time permits, and tomorrow we'll start with cat boost. Uh, so give me just 2 more minutes. We'll start at 10:10. So Nishta, you had any question? Uh, now I need to create the bag for new model M2. Okay. तो अब M2 मॉडल पूरा पूरा डेटा पे डिपेंड करता है, हर मॉडल डेटा पे डिपेंड करता है। तो जो डेटा इसमें आए वो कौन सा हो, वो डेटा डेफिनेटली रैंडमली इसमें से, बट क्या हम उस सैम्पलिंग को वेट के बेसिस पे हैंडल कर सकते हैं? यस। सो द सैम्पलिंग दैट हैपेंस हियर दैट टेक्स केयर ऑफ द वेट, and that means the records with higher weights have more probability of passing into this. And it's not only the probability, it's even ये वाला रिकॉर्ड हो सकता है कि 3-4 बार यहाँ चला जाए, ये वाला रिकॉर्ड 3-4 बार यहाँ चला जाए, जबकि बाकी रिकॉर्ड एक बार हो या हो ही ना। कुछ रिकॉर्ड एक ही बार होगा या कुछ होंगे ही नहीं, लेकिन ये रिकॉर्ड तो 2-3 बार भी हो सकता है, बिकॉज जब वो रैंडम सैम्पलिंग हो रही है विद रिप्लेसमेंट, तो इट्स अगेन एंड अगेन बिकमिंग अ पार्ट ऑफ दिस डेटा सेट, सो दैट जब ट्री बिल्ड होगा तो ट्री पूरा पूरा डेटा पे डिपेंड करता है, राइट? तो वो रिकॉर्ड जो ज्यादा बार आ रहा होगा वो उस ट्री को बनाने में ज्यादा मदद करेगा। एक तरह से कह सकते हैं कि उस ट्री ने उस पर्टिकुलर एरर रिकॉर्ड के ऊपर अपना लर्निंग अच्छे से की होगी, क्योंकि उसका वेट उस ट्री में ज्यादा था। तो इसलिए हम कहते हैं कि M2 जो है वो एरर रिकॉर्ड्स को तो सही से क्लासिफाई करेगा ही करेगा, क्योंकि जब ट्री बन रहा है तो जो गिनी है, गिनी किसके बेसिस पे कैलकुलेट होता है? गिनी की पूरी पूरी जो कैलकुलेशन है उसमें रिकॉर्ड्स की तो प्रोबेबिलिटी है कि आखिर कौन सा रिकॉर्ड किस लीफ में फॉल कर रहा है या किस साइड पे फॉल कर रहा है, उसके बेसिस पे आप जो भी अपनी गिनी या एंट्रोपी कैलकुलेट करते हो वो पूरी पूरी इसी पे तो डिपेंड करती है कि आपका रिकॉर्ड सही से क्लासिफाई हो रहा है या नहीं हो रहा। That's what the Gini or entropy is. The probability of a record being properly classified. So this record, if getting rightly classified, will increase the Gini, and then this tree will be built in that way. Okay. Okay. So this was about the adaptive boost model. तो एडा बूस्ट में बस इतना होता है कि आपके सब्सिक्वेंट ट्रीज जो बनते चले जाते हैं, एक ट्री के बाद दूसरा, तीसरा, चौथा, ऐसे आपके पास बहुत सारे ट्री बनते हैं। ओके, लेकिन सीक्वेंशियली बनते हैं, इसलिए वो स्लो होता है। लेकिन स्टिल इट्स नॉट स्लो, बिकॉज यहाँ डीप ट्रीज नहीं बन रहे हैं, यहाँ सिर्फ स्टम्प्स बन रहे हैं, सिर्फ स्टम्प्स बन रहे हैं। ओके, रिमेंबर दैट। अगर यहाँ डीप ट्रीज बनने लगते हैं तो ये स्लो हो जाता एज कंपेयर टू बैगिंग, बट सिर्फ स्टम्प्स बन रहे हैं। दूसरी बात, हर स्टंप की अपनी एक इंपॉर्टेंस है यहाँ पे। ओके, सारे स्टम्प्स इक्वली इंपॉर्टेंट नहीं है, जैसा कि हम कल बात कर रहे थे। ओके, तो जब आपके स्टम्प्स बन जाते हैं फाइनली, मान लो आपके स्टम्प्स बन गए, आपका 1 2 3 4 5 6 स्टम्प बन गए। यहाँ स्टम्प का साइज एक्चुअली वो बड़े छोटे ऐसे दिखा रखे हैं कि उसका अमाउंट ऑफ से क्या है। इसका अमाउंट ऑफ से 0.97 है, इसका 0.32 है, 0.78, 0.63, 0.41, 0.82, ऐसे बहुत सारे ट्री बन रहे हैं। बट ये याद रखना कि ऐसा नहीं होता कि जो ट्री पहले बन गया उसका वेट ज्यादा होगा या इंपॉर्टेंस ज्यादा होगा, जो बाद में बन रहा है उसका इंपॉर्टेंस कम होगा, ऐसा नहीं है। इट ऑल डिपेंड्स ऑन दैट फॉर्मूला which I told you yesterday, the exponential formula. So amount of say is calculated based on that, कि भैया मॉडल ने कितनी टोटल एरर है, use that total error, like 1 minus total error by total error and exponential, that formula you get the amount of say. अब जब मान लो आपको कोई नया रिकॉर्ड आया जिसको आपको प्रेडिक्ट करना है, मान लो आपको प्रेडिक्ट करना है कि भाई पेशेंट का डेटा है, उसको डिजीज है या नहीं, तो इस ट्री ने बोला कि भाई उसको डिजीज है, इसने भी, इन चारों ने तो बोला कि भाई उसको है, इन दो ने बोला नहीं उसको डिजीज नहीं है। तो नॉर्मली तो हम क्या करते, मेजॉरिटी वोटिंग से जाते, तो हम कहते कि भाई उसको डिजीज है क्योंकि 4 लोग बोल रहे हैं। लेकिन यहाँ ऐसा नहीं होता कि भाई 4 लोगों ने बोल दिया तो हमने बोल दिया ना। यहाँ पर होता है कि भाई उनकी इंपॉर्टेंस कितनी है, जिन्होंने हाँ बोला है उनकी सबकी इंपॉर्टेंस को ऐड करो, और जिन्होंने ना बोला है उनकी सबकी इंपॉर्टेंस को ऐड करो। कौन सा ज्यादा आ रहा है, ये आ रहा है 2.7, ये आ रहा है 1.3, तो हम मैक्सिमम वाले को मान के चलेंगे, राइट। तो दैट्स व्हाट यू हैव टू अंडरस्टैंड। लेकिन अगर वहीं इन सबका इक्वल वेट होता तो 1 1 1 1 1, तो यहाँ पे आती वैल्यू 4, और यहाँ 2 2 होता तो यहाँ आती 2। तभी भी मतलब अगर नॉर्मल वोटिंग भी होती तो भी यही साइड जीतती। बट लेट्स कंसिडर अ सिनेरियो कि यहाँ पर भी 4 ट्री आ गए, ठीक है, यहाँ पर भी 4 ट्री है, यहाँ पे भी 4 ट्री है। अब यहाँ पर एक बोल रहा है 0.40 और एक बोल रहा है 0.50, मतलब उसकी अमाउंट ऑफ से के साथ, उसकी जो इंपॉर्टेंस है उसके साथ, कि भैया इसको डिजीज नहीं है। ओके, ये कोई प्रोबेबिलिटीज नहीं है। ओके, ये दीज आर नॉट प्रोबेबिलिटीज, दीज आर द इंपॉर्टेंस ऑफ दैट ट्री, दिस इज नॉट द प्रोबेबिलिटी। प्रोबेबिलिटी तो उसने दे दी कि भैया उसको डिजीज नहीं है। अब लेकिन यहाँ इक्वल इंपॉर्टेंस वाला केस होता तो हम फंस जाते, बिकॉज 4 यहाँ 4 यहाँ, आप डिसाइड ही नहीं कर सकते कि आखिर उसको प्रॉब्लम है या नहीं है, डिजीज है या नहीं, राइट। बिकॉज मान लो आपने 8 ट्री यूज किए थे, 4 ने हाँ बोल दिया, 4 ने ना बोल दिया, यू आर स्टक। तो और यहाँ ऐसा भी नहीं होता है कि आपके जो नंबर ऑफ ट्रीज होते हैं वो ऑड रखने हैं, इवन रखने हैं, आप कुछ भी रख सकते हो, ऑड भी रख सकते हो, इवन भी रख सकते हो। तो अगर आपने नंबर ऑफ ट्री इवन रखे, 4 ने हाँ बोल दिया, 4 ने ना बोल दिया, तो यू आर सॉर्ट ऑफ स्टक, राइट। तो the boosting also helps you in that place, even any weighted analysis helps you in that way, कि भाई अब मुझे इससे तो मतलब ही नहीं है क्योंकि इक्वल इंपॉर्टेंस नहीं है। सबकी इंपॉर्टेंस कितनी है, इनकी आ गई 2.7, इन सबकी इंपॉर्टेंस कितनी आ गई, इसमें 0.9 और ऐड कर दो तो 2.13 करीब करीब, चारों अगर मैं ये चारों ऐड कर दूं तो अब भी ये 2.7 इज हायर, तो आई विल से कि भैया ही इज हैविंग अ हार्ट डिजीज, राइट। सो दैट्स द डिफरेंस बिटवीन अ वेटेड model, simple boost bagging model, where each one has the equal importance and something. Here it's not the case. Here it's the amount of say that gets added. Okay, so before we go ahead, any questions before I go into the gradient boosting model? No. Okay. So Gulzar, I'm actually don't want to divert from the things. So its mod tomic is more related to undersampling, oversampling. So just forget it. It's related to one question I was answering. Tomic and SMOT is okay. So undersampling, oversampling. Okay, leave it. Okay, use होते हैं. Hamiz, I cannot give you what I am using in my industry, but we are using these models. Okay, so there is nothing like boosting are not used. So bagging and boosting, ideally bagging and boosting are the models which we use in the industry. We lesser use a individual model like a weak learner or a base model like a single decision tree or a single KNN. We use ensemble models in industry because we have high computation power, so that's not a problem. But those who don't have a huge computation power, they may restrict themselves to base model, or not they don't go to the ensemble models because they don't have the computation power. But in industry we have it. Okay, hackathons में भी आप एक लिमिटेड काइंड ऑफ मॉडल्स ही ट्राई करते हो क्योंकि आपके पास भी कंप्यूटेशन पावर नहीं होती। मतलब आप न्यूरल नेटवर्क्स वगैरह ट्राई नहीं करते, एडवांस न्यूरल नेटवर्क्स, बिकॉज आपके पास वो कंप्यूटेशन पावर नहीं है, आपके पास जीपीयूज नहीं है, सीपीयू पे ही चलाना है आपको, राइट। तो इट ऑल डिपेंड्स कि आपके पास कंप्यूटेशन सॉल्व करना चाहते हो। ऐसा मत सोचो कि भाई क्या है, आप क्या प्रॉब्लम करना चाहते हो, ऐसा कभी मत सोचो कि ये मॉडल मैं इसलिए यूज कर रहा हूँ or it's not like that. Models are primarily used for solving the problem. Whichever model helps you solve that problem, you should use it. Okay, whether it's bagging, boosting, or even a single support vector, it's all on the problem. But at the same time, क्या आपके पास कंप्यूटेशन पावर है? वरना तो हर कोई आज न्यूरल नेटवर्क यूज करना चाहता है, जबकि न्यूरल नेटवर्क का कोई इतना हर केस में फायदा नहीं है. You should not use neural networks everywhere. Okay, तो it all depends कि आपके पास कंप्यूटेशन पावर क्या है, आपकी प्रॉब्लम स्टेटमेंट क्या है, right? Most of the things can be solved without neural networks, right? So we use boosting, bagging, even support vector machine or logistic regression. They are very good models. Okay, तो हैकेथॉन्स में कोई अपना टाइम ज्यादा लगाना नहीं चाहता तो वो सीधा बूस्टिंग मॉडल पे आ जाते हैं. They don't want to tune this support vector machines. Otherwise, support vector machine या logistic regression can also help you in good results in a hackathon. Okay, but और भी कुछ रीजंस होते हैं कि आपकी कुछ लेवल ऑफ फीचर इंजीनियरिंग भी हैंडल हो जाती है इन मॉडल्स में, जैसे स्केलिंग वगैरह एडवांस मॉडल्स में. तो कई बार लोग रीस्केलिंग वगैरह हैंडल कर रहे हैं तो वो बूस्टिंग यूज कर लेते हैं. बट इंडस्ट्री में हम स्केलिंग खुद करते हैं, हम मॉडल पे रिलाई नहीं कर सकते, राइट? तो बिकॉज हमें पता है हमारा डेटा किस तरह का है, तो हमें खुद स्केलिंग करनी होती है. फिर मॉडल फर्दर कुछ कर रहा है तो अलग बात है, बट we don't want to pass the raw data. Okay, so that's how pressure the things are. Industry uses these models. Okay, it's not like industry don't uses these models. Okay. Yeah. So all the normal models runs on the CPU, but the advanced models like neural networks and all, they runs on the GPU. But it's all configurable. Okay, you for neural networks we can change whether we want to run it on CPU, GPU. And there is one more thing. Okay, like CPU, there is GPU, and then there is TPU. Okay, so like CPU is there, GPU is there, then there is a TPU which is given by Google, which is a TensorFlow processing unit. Okay, so people are talking about these things also, TPUs, but you can read about this. For running the neural networks, you can run on your laptops, but it will be quite slow. That's the only thing here, because you normally don't have high graphic cards or you don't have high GPUs or TPUs. But it's not like they will not run. It will run. But the best thing is you should have a high-end laptop. You can look at the internet, the laptops that supports high-end graphics, like gaming laptops and all. They are quite good. Okay, but still, these laptops also runs. That's not a problem. Okay. Okay. So yeah, TensorFlow can still run on your laptops. मतलब TensorFlow आप जो TensorFlow या Keras यूज करते हो, ऐसा नहीं है कि TensorFlow के लिए आपको GPU चाहिए ही चाहिए. They can still run on the CPU, but yeah, it will be slow. TensorFlow and TPU are two different things. Okay. TPU की full form होती है TensorFlow Processing Unit, but they are completely different from tensors. Okay. Tensor क्या होता है? Do anyone know what are tensors? Those who are from maths maybe. What are tensors? So tensors are nothing but like you have vectors and matrix, right? So you have vectors, matrices, which are sparse matrix, right? So tensors are nothing but that only. मतलब क्या होता है कि आप ज्यादा डेटा कम जगह में सेव करना चाहते हो. मतलब you want to optimize the storage so that your processing is also optimized. So tensors are actually you can say the mathematical objects that help you storing the data in a more efficient manner. Okay. So जैसे कि हम कल स्पार्स मैट्रिक्स की बात कर रहे थे, एज कंपेयर टू अ pandas data frame, we saw कि 45 million elements थे, लेकिन सिर्फ अराउंड 45,000 ही नॉन जीरो एलिमेंट्स थे, तो हम सिर्फ 45,000 एलिमेंट्स ही सेव करें, 45 मिलियन सेव करें, तो आपका नमपी पैकेज था, उसने उस चीज को हेल्प किया अचीव करने में, राइट? तो उसी टेंसर्स को जब एक टेंसर से दूसरा टेंसर जब लिंक होता चला जाए, यूज कर सकते हैं, जीपीयू भी यूज कर सकते हैं, बट गूगल कहती चीज को एफिशिएंटली, राइट? तो मैं कह रहा हूं मेरा मॉडल 1 घंटे में चल रहा है, सेम डेटा पे एक डेंस एरे या डेंस मैट्रिक्स यूज कर रहे हो, मैं स्पार्स मैट्रिक्स यूज कर रहा हूं। फर्दर मैं टेंसर यूज कर रहा हूँ, टेंसर फ्लो ट्रीप्यूज यूज कर रहा हूँ, चीजें उस हिसाब से ट्यून होती चली जाती हैं। ओके, so there is still even a company which is famous for making the models running very very fast. Do anyone heard about H2O, guys? Anyone of you heard about H2O? Yeah, very good, Pragasha. So guys, you should be so H2O is the company which when started, अभी तो ये बहुत mature हो गई है, but like say 6 years back when I used to study about these fields, this was a very nascent company and their purpose was just to make the models run fast by giving you a mathematical structure which is processing good for a huge amount of data. Okay, go through H2O, and H2O have packages for R, for Python. Okay, so you can do quick install the H2O package, and then there is a lot of things in the industry. This sparkling water is something quite famous. It's for those of you who may know about big data, Spark. So they work with big data Spark, and that's what sparkling water is. Okay, so H2 have a whole mathematical library that that you can definitely go through. अभी तो मतलब इन्होंने अपना पूरा प्लेटफॉर्म बना दिया है, बट दे हैव R and Python packages also that you can work on R and Python. बट अभी तो ये फुल फ्लैश खुद का एक एनवायरनमेंट है कि आप इन्हीं के एनवायरनमेंट पे लॉगिन करके काम कर सकते हो सारा इन्हीं के प्लेटफॉर्म पे. Okay, so just go through it, like how they have optimized the GLM, GBM, XGBoost, okay, word to vector, and I'm just looking for one thing. 1 second. Because see, where the things like H2O helps you is when you talk about deep learning and neural networks, right? So there we talk about lot of data. So there we need systems which are mathematically quite enhanced or advanced as compared to other systems. So go through this. So this is actually a platform mainly for advanced mathematical computations. It uses now TensorFlow and all those things also. Yeah, go through it. Just try if you can do pip install H2O. So that's fine. You can try it later. Uh, it's H2O. Actually, I typed 0. Yeah, you're correct. It's H2O. So it's not H20. But definitely you can get it from the internet. What is the exact package name if H2O is not working? Uh, yeah, it's working. So it's getting downloaded. So there are a lot of things actually. Okay, so going back to the things we were talking about. So बूस्टिंग मॉडल का सिंपल फंडा ये है, कोई भी बूस्टिंग मॉडल होगा, पहला मॉडल दूसरे मॉडल में अपनी एरर्स पास करना होगा, सिंपल सी बात है, और दूसरा मॉडल पहले वाले की गलतियों से रहा होगा कि आगे गलतियां करनी, सिंपल, that's all boosting model do. But now there are senses in the implementation. Okay, so that's what we are going to talk now. So now we are going to talk about the gradient boosting model, guys. So what the gradient boosting model do? So now we will implement next tree model, then we will implement another tree model. Yes, Nishta, absolutely. If you guys want, you can go through it. So there are a few important videos I will share with you guys, uh, so that you can go through it, but there are some mathematics which you might not get there directly. So there are 3 or 4 famous YouTube channels I will share with you. Okay. So what you have to understand, guys, the very first thing which any regression model do is you have to have the base model. So base model is built. Now you keep on building the subsequent models building. So this will predict something, this will predict something, this will predict something, and here the output is the addition of all the predictions. Whatever this tree predicts, this tree predicts, this tree predicts. So the output is just the sum of all of these. Here we are not doing like average. Okay, we are not doing that. Like in bagging, agar ek regression tree hai, you do average, right? That's what used to happen. But here it's not the case. Okay. Even in the example before, the ADA boost, you are doing the average if it's a regression problem. Okay. But here it's not the case. Here, each tree will predict something and you will just keep adding that. Now the question arises कि अगर हर ट्री वेट ही प्रेडिक्ट कर रहा है तो वेट बहुत ज्यादा हो जाएगा. तो यहाँ पर ऐसा नहीं होता. यहाँ पर सिर्फ पहला जो ट्री है वो आपका वेट प्रेडिक्ट कर रहा है आपका. बाकी जितने भी ट्रीज हैं वो आपके रेजिडुअल्स प्रेडिक्ट करते हैं, द एरर्स. ओके, मींस इस प्रेडिक्शन के बाद फर्दर अगर कोई मॉडल आप बनाओगे, वो मॉडल ये ट्राई करेगा कि एरर कितनी कम से कम मैं प्रिडिक्ट कर सकता हूं, और वो एरर्स आपके इस बेस वैल्यू में ऐड होती चली जाएंगी. वी विल अंडरस्टैंड दैट, बट आई वांट टू गिव यू फर्स्ट द बेसिक बिहाइंड इट, द लॉजिक बिहाइंड इट. यहां पे भी सब्सिक्वेंट ट्रीज बनेंगे, बट यहां पर first of all trees are of equal importance. That's one thing. Second, here we are not doing averaging or something like that. We are just adding the output of each tree. Okay, here your trees are not predicting the output, rather they are predicting the errors. We add all the errors, or rather we should say it as a residual. You will understand that it's we add all the errors or the residuals rather. So what that means we will see. So here, but the another difference, like if someone asks you in an interview, right, difference between ADA boost and this is, in ADA boost, your trees of the length 1 or the stumps, here your trees can be deep trees. Okay, here your trees can be deep. Each individual tree can be deep. We don't want it to be very deep, so we have a pruning criteria where we set the number of leaves that we want. Okay, so number of leaves is another pruning criteria, right? So normally if data is less, you can say okay, now if you have less data, you can say कि stop once you reach to 5 or 8 leaves, that's it. But if you have millions of records, you can increase this value, and you can go like up to maybe some 40, somewhere around 40. Okay, normally people says okay, go from around 30 to 40 on a higher side, and 5 to 8 on a lower side. Okay, so if you have lesser data like 100,000 records, 100 or 1000 records, 5 or 8. But if you have millions of records, or you have like 10,000, 20,000, like that, you say okay, number of leaves 30, 40, like that. Because any decision tree, उसका पर्पस क्या होता है? किसी भी डिसीजन ट्री का पर्पस ये होता है कि अल्टीमेटली ये जो फाइनल लीफ नोड बने, इस लीफ नोड में, गाइस कैन एनीवन टेल मी, किसी भी डिसीजन ट्री का पर्पस क्या होता है? कि इस लीफ नोड में फाइनल नोड में एक रिकॉर्ड हो, या ग्रेटर देन 1 रिकॉर्ड हो, या 0 रिकॉर्ड हो. इन तीन में से कौन सा ऑप्शन है, ए, बी और सी? व्हेन यू बिल्ड एनी डिसीजन ट्री, a good decision tree, what do you want to achieve at the leaf nodes? Each leaf node has one observation, greater than one observation, or 0 observation. When you train a tree model, please ping me. Okay, that's, I'll come to that later, Aditi, homogeneity. But first, guys, what is the purpose? Whether it should be 1, greater than 1, or 0. Okay. So guys, I'm asking, yeah. These are just the trivia questions, okay, that comes to you. I want more people to reply. I just see Aditi, Nistha, no, not others. Guys, others, they haven't worked on decision trees. Okay. So far, all of you are wrong. Wrong, wrong. Okay. So see, it's very simple, guys. If uh, definitely not zero, at least that's good. Because अगर zero होगा, तो वो node ही exist नहीं करेगी. Simple. Now it can be either one or greater than one, right? So answer should not be one, because one means it's a overfitted model. Okay. If you have 1 1 1 1 1 at each leaf node, that means that tree will be very deep. That's the first thing. Okay. If you have 1 1 record, say if you started, consider it like that now. If you started with 1 million records, you want to train 1 million records, your tree, when it will be built, it will be built such that you have 1 million leaves, guys. You have 1 million leaves. ये तो मैं आपको बता रहा हूँ कि 1 मिलियन लीव्स होंगे, लेकिन उन 1 मिलियन लीव्स को रिप्रेजेंट करने के लिए ट्री कितना डीप चला जाएगा? आर यू गेटिंग इट? If you say that at each node you should have this value as 1, and that's the straight rejection from the interview. Okay, because decision tree is the most common thing and you are not able to understand the logic. Okay, so understand that if you say 1, that's the wrong answer. It should be more than 1. Okay, so the purpose of building a tree is such that at the leaf nodes you have more than 1 records, and once you have more than 1 record, you then come to the point that Aditi was saying is homogeneity. So say if I have a no, so still it's homogeneous, but not to that quality which 400 were. All 400 were. If the wrong records are falling in the wrong bucket or the wrong leaf, right? So remember that the purpose of building any decision tree is to make sure that at the leaf level you don't have one single record, you have more than one record. And that's why you have min split and min bucket, right? Otherwise, why will you put min split and min bucket? Likely like कि final leaf node पे एक एक record डाल देगा वो, तो फिर pruning करने का फायदा ही क्या हुआ? Okay, so understand that you have to avoid overfitting by doing pruning, and that's where the question of homogeneity and all comes in. Because अगर एक leaf पे एक ही record है, तो how will you say कि वो homogeneous है या नहीं? You cannot. Okay, because one is always homogeneous. Rather, that's a waste. And that. So that's the first point, that why we build trees, what's the logic behind the tree, what is the logic even behind pruning a tree or avoiding a overfitting, okay, logically. And here we talk about building deep trees, but only up till say the length of 8 to 40, somewhere in between. That's a good range. Okay. So now we built the first tree. Rather, the first tree in this case is not even a stump, it's just a node. Okay. Now the second step here is, what's the second step, right? So in AdaBoost, what you do is you were getting some errors, right? The errors on the basis of which you were changing the weights, right? So here also we need to find errors. Considering that only this was my base model, what will be the error? Actual minus predicted, right? Actual minus predicted will be the error. Like 76 minus 71 will be the error. 56 minus 71 will be the error, right? अगर मैं यहाँ पे errors का column बनाऊं, because boosting you need errors, because error नहीं होगी तो कुछ पता नहीं लगेगा. तो first model will help you to get a new residual column or a pseudo residual column. So if you come here, guys, if you look here, so this is what minus 71, like that, it keeps on going. So there will be residuals. So if you see here, there will be residuals, right? Now you have this full set of residual. Once you have this residual column, उसके बाद अब नेक्स्ट ट्री बनेगा. उसमें भी यही होता था कि पहले हम एरर्स निकालते थे, एरर्स के बेसिस पे वहां सैम्पलिंग होती थी डेटा की. राइट, वहां डेटा की सैम्पलिंग होती थी और फिर मॉडल चलता था. ठीक है, लेकिन यहाँ डेटा की कोई सैम्पलिंग नहीं हो रही. सारा का सारा कॉलम, गाइस, फॉर दिस न्यू ट्री दैट आई एम गोइंग टू बिल्ड, पहला तो मैंने नोड बना ही लिया. पहला ट्री तो सिंगल एक नोड है. अब प्लस कर रहा हूँ, अब सेकंड ट्री बना रहा हूँ. बट हियर द सेकंड ट्री दैट आई एम गोइंग टू बिल्ड is having the target as residual, not the weight. So now I want to predict कि भैया residual क्या होगा. अगर ये combination of features है मेरे पास, तो ये मेरे पास residual values हैं, तो it's like regression tree, but the target is residual. Okay, so using the Gini index again, internally the model decides that given this data set, now this is the new data, right, for the next model. New in the sense that my target has changed. Split हो सकता था. Further it could have splitted until it reached a place कि हर लीफ नोड पे एक सिंगल रिकॉर्ड ना आ जाए, तब तक स्प्लिट होता रहता. अच्छा, कोई मुझे ये बताएगा कि अगर एक कॉलम आपका स्प्लिट करने में एक नोड पे यूज हो गया है, जैसे यहाँ जेंडर यूज हुआ है, यहाँ हाइट यूज हुआ है और यहाँ पर कलर यूज हुआ है, तो क्या अगर एक कॉलम एक बार यूज हो गया वो दोबारा यूज हो सकता है स्प्लिटिंग के लिए? Guys, another important interview question, trivia question. I want answers from others. Those who says no, guys, that's not the answer actually. One column can be used again. Okay, it's not the column who's taking the decision, right? Whether I should be a part of split or not. It's the model who is taking the decision, right? So होता क्या है कि अगर मान लो इस लेवल पे अभी मुझे पता नहीं किस कॉलम पे स्प्लिट होना है. Okay, I don't know that, right? So all of these three columns actually will take part here. Remember, guys, all of these three. Okay, so एक कॉलम एक बार स्प्लिट के लिए यूज हो गया है, ऐसा नहीं है वो दोबारा यूज नहीं हो सकता. it's just random features that model picks. Say for example, if I have 100 features, randomly pick any 10 to decide out of those 10 which can be best. But वो random 10 ऐसा कोई उसमें हो सकता है जो पहले कहीं यूज हो चुका हो. ओके, ऐसा नहीं है कि यूज होगा तो वो but उसका ग्रैंड पेरेंट या ग्रैंड पेरेंट can be used. Okay, it can be used. So just remember that direct parent will not be used, but the grandparent or grandparents or ancestral parents, they can be used. Getting it right. So remember these things.
Sir.
Yes.
Sir, so you mean to say that if we're looking at this picture, then so residual वाला block है green color में, so that can be further split on the basis of gender.
But for that we have to look in the data. That can happen. It's not like that it cannot happen. I understand, because you are saying that, yeah, because you are saying कि ऊपर से ही filter होता बाहर है वो data, right?
Yeah.
So if you want, I will give you an example. I have to give you some. In this case, it may not be a good example because here it's a categorical column. Okay. So okay, let me explain you here only. इसकी सिर्फ f की दो ही values हो सकती हैं, but ऐसा तो नहीं है. f की value दो से ज्यादा हो सकती हैं. तो यहाँ उसने कहा gender is f. तो यहाँ पर ये थोड़ी है कि ये जेंडर एफ का डेटा है, मतलब यहाँ पर ये है कि चलो यस है और यहाँ पर है नो. ओके, तो अब इस केस में तो यहाँ पर चलो आपका सारा एफ का जा रहा है, तो दिस विल नॉट मेक एनी सेंस इन दिस पर्टिकुलर एग्जांपल आई एम सेइंग, बट ऑन दिस साइड it will make sense, right? So if you go by data, this branch will be for you. Okay, it should be eligible because there can be multiple other values of gender, right? So this side of the tree can use gender anywhere further because it may be transgender, not specify, or maybe male, some other things, right? So does that answer your question, Nisha? Yeah, go ahead.
Yeah, somewhat. Sir, so when we talk about continuous variable splitting in a decision tree, so it makes the differences on the basis of a cutoff value where it separates out greater than this and then smaller than that particular value.
Absolutely.
So in that case, how will you how will the leaf node further split the parent grandparent node? Because they have already been segregated.
No, I'm telling you. Okay, I got it. These are the decision tree concepts. Okay, so see, I split here saying height should be less than 1.6, right? I could have splitted this further again on the basis of height also, and this time I would have said height less than 1 or not. I'll come to your point. बिकॉज यहाँ पर सारे कौन से लोग हैं जिनकी हाइट 1.6 से कम है, राइट? लेकिन फर्दर मैं अब इस डेटा को फर्दर इस डेटा को स्प्लिट कर सकता हूं से क्या हाइट अब 1 से लेस है, तो अगर यस है तो इट मे गो देयर, अगर नहीं है तो इट मे गो देयर। तो ये जो थ्रेशोल्ड होता है, ये थ्रेशोल्ड 1.6 कैसे डिसाइड होता है, उसके पीछे पूरी महाभारत है, बहुत लंबी। क्या होता है कि ये सबसे बड़ा टाइम टेकिंग टास्क है। जब आपको ये करना होता है थ्रेशोल्ड, तो मॉडल क्या करता है, मल्टीपल ट्राई करता है, मिनिमम एटलीस्ट 3 फॉर मान लो 1 से 10 के बीच में पॉसिबल वैल्यूज थी हाइट की। मॉडल विल ट्राई, say initially model tries a value, say let's say it tries 2 values, maybe 5 and 10। 1 से 10 के बीच में वैल्यू थी, let's say model tries 5 and 8, model tries 2 in बीच की 2 values, and then it compared the guinea and it came to know, okay, this one is coming better, right, as compared to this. So model will say कि my area, the next level of analysis should be within this range, because 5 was the one which was giving you a better value. Then models selects some values within this range in between this to see कि भाई क्या 5 से भी लेसर कोई ऐसी वैल्यू है जो और records. Here the threshold was calculated on the 100 records. So you're getting it, Nishtha. First of all, how these thresholds are decided. These thresholds, why they can be different, because here they were on the 100 records, here they were on the 10 records, which were eligible for split. Okay. So go through how the decision tree actually splits internally. Okay. Take some sample data and do it using pen and paper. Don't just go through program. Do it mathematically. Calculate Gini, take some data, then it will be clear. Otherwise, there will be problems. Take only 3 columns and just run it through a mathematical formula. You will get to understand it.
Okay.
Any further doubts?
Sir, one more. Yes, sir. Sir, when we talk about when the Gini index has been calculated and it takes out the root node to be a specific variable out of a data, so when it chooses the root node, it further splits it on the basis of the amount of data, or that also is a Gini index only. Like it separates it on an equal basis, or
नहीं मैं क्वेश्चन नहीं समझ पाया।
देखो जैसे हमारी डिसीजन ट्री,
हाँ बोलो,
जैसे हमारी डिसीजन ट्री ने डिसाइड कर लिया कि कौन से वेरिएबल पे उसे स्प्लिट करना है, रूट नोड बनाना है, तो
बिल्कुल
the next further when it splits it, So it splits it taking the quantity on both the splits equally, or that too is also on the Gini basis?
नहीं 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 नहीं, अरे मतलब एक बार जब उसने ये डिसाइड कर लिया किस कॉलम पे स्प्लिट करना है, उसको रिकॉर्ड से कोई लेना देना नहीं है. अगर यहाँ 100 रिकॉर्ड्स थे, उन 100 रिकॉर्ड्स ने मिलके आपको ये बता दिया ना कि हाइट लेस देन 1.6 गिविंग मी लेस लीस्ट गिनी, द बेस्ट गिनी, लेट्स नॉट से लीस्ट और मैक्स, द बेस्ट गिनी वैल्यू. तो उसके बाद योर मॉडल विल चेक ऑल दोज रिकॉर्ड्स which satisfies that criteria. Simple. तो अगर 100 रिकॉर्ड थे, उसमें से कौन कौन से रिकॉर्ड है भैया जो 1.6 से लेस हैं? ये है, नहीं है, नहीं है, ये है, चलो भाई इसको लेफ्ट साइड पे ले जाओ, इसको लेफ्ट साइड पे ले जाओ, इसको लेफ्ट साइड पे ले जाओ. तो देख रहे हो ये 1.6 से लेस जो होंगे वो लेफ्ट साइड पे आ जाएंगे, और जो 1.6 से ऊपर वाली हाइट होंगी वो आपके राइट साइड पे आ जाएंगे. दैट्स हाउ द मॉडल विल वर्क.
Okay, so that's all based on the mathematical formula that is used behind.
Absolutely,
That's
absolutely.
the balance of the data, balance of the volume.
No, never. It's all driven by the data. That's why it's a data-driven model. Decision tree is the data-driven model, highly overfitted on the data, right? That's why this is having the highest variance. जैसे ही आप नया डेटा दोगे, डिसीजन ट्री बिल्कुल बदल जाता है, because it's having that level of problems. Okay, तो अब यहाँ अगर आप देखोगे तो 1, 2, 3 रिकॉर्ड्स ऐसे थे जो कि यहाँ पे आने चाहिए थे, लेकिन 2 ही आए हैं, क्योंकि हाँ एक मेल का, तो वो इस साइड पे गया होगा, क्योंकि इस साइड पे तो सिर्फ फीमेल के रिकॉर्ड्स है ना. तो फीमेल के 2 ही रिकॉर्ड्स हैं जो कि हाइट 1.6 से लेसर वाले हैं, ये वाला है और ये वाला है. तो इट्स ऑल डेटा ड्रिवन. इट्स नॉट लाइक आधे इधर जाओ आधे इधर जाओ और बाकी वहीं रह जाओ. सो नथिंग लाइक दैट. It's like whatever follows this formula.
Yes, okay, sir.
Okay, clear?
Yes, sir.
Okay, perfect. So now if you look at this thing, what I'm trying to explain you is कि जो भी decision tree आपका बन रहा है, वो क्यों बनता है, उसके पीछे क्या reasons है, logics है, remember all these things. But now once this tree is built, okay, once this tree is built, now if I want to predict for any new record in future, so that new record, if it comes and fall here, value will be 4.8. It comes and 4.8. But what if that record comes and falls here? Should I predict 14.2 or for 15.2? I don't know that, right? So वो तो regression में भी हमने बात की थी पहली क्लास में. Average. We take average of the records. In regression, we take the average of the data that is here. So any data that will fall here, so that will predict value as minus 14.7. Okay, that's the work of regression tree. तो यहाँ पर अब आप लोग देखेंगे तो सीधा सीधा रेसिड्यू प्रेडिक्ट किया है, एरर, द रिमेनिंग एरर जो आपका पहला ट्री प्रिडिक्ट नहीं कर पाया. समझ रहे हो? अल्टीमेटली यहाँ पर हो क्या रहा है? The first tree was just an average model. It was not a good model. But the next tree is trying to predict that part which the first model missed. वो छोटा सा delta, the delta which the first model missed. So that delta is either minus 14.7 means मैंने 70 बोला था. Let me show you this. Yeah. If you look at this now, how the model will be, the next step. Say a new record will come to this model and you will say the value is 71.2, but अगर उसकी actual value थी 80, तो आपके सिस्टम में अभी 9 का एरर है, राइट? 9 का एरर है. तो सब्सिक्वेंट मॉडल्स उस 9 का एरर जो आया उसको रिमूव करना चाहते हैं. तो अब ये डेटा इस मॉडल से जाएगा, 71 की वैल्यू आ जाएगी, फिर ये डेटा इस वाले मॉडल से जाएगा, एंड मान लो इससे जाते जाते उसने यहाँ पे फॉल कर गया, तो तो 4.8 आ गई. तो ultimately 71.2 plus 4.8 is how much? 76, right? So overall this tree will predict now 76, which is still closer to the actual value, guys. So that means you are taking small steps to reach to the actual value. अभी तो यहाँ पे सिर्फ 2 ही ट्री हैं. अब मैं इसमें एक और ट्री अगर ऐड कर दूं, वो कुछ और एडिशनल एरर जो मॉडल में रह गई थी उसको निकाल के लाएगा, डेल्टा को. मान लो उसने भी उसमें 5 की वैल्यू ऐड कर दी, तो 76 plus 5 is like 81. So 81 is still better, closer to 80. So I can say that this model with 3 trees, like 1 base node and 2 deep trees, is actually a good model, right? Because this is how it works. Each next tree is just predicting the remaining error in the first set of models. Okay, so let me go to the next step. Now this learning rate, right? What is this learning rate? So here learning rate can be considered as the parameter that helps you to balance the overall output, the overall calculation. Learning rate normally 0 से 1 के बीच में होता है, right? तो यहाँ पर भी आप 0 से 1 में कोई भी वैल्यू रख सकते हो. Ideal values are like 0.1, 0.1, 0.2. बट लर्निंग रेट यहाँ पे सब ट्री का सेम होगा. अगर आप 10 ट्री बनाते हो तो 10 के 10 का सेम लर्निंग रेट होगा. ऐसा नहीं है कि हर ट्री का अपना अपना लर्निंग रेट है, वरना वो तो वेट ये वेट नहीं है. दिस इज लर्निंग रेट विच इज सेम अक्रॉस द ट्रीज. दिस इज जस्ट टू बैलेंस द रेसिडुअल्स, द रेसिडुअल्स दैट यू आर गेटिंग, वो बहुत ही हैवी ना हो जाए. वो उनकी वैल्यू को एक रेंज में ले आता है लर्निंग रेट. ओके, लेट्स सी दिस what happens at the next step. So you have the base model and you have the second model. Second model predicts 16.8 for example, and what you will do, 71.2 plus सीधा सीधा मैं 16 इसमें ऐड नहीं कर रहा. 16 को मल्टीप्लाइड बाय 0.1 सो दैट कि बहुत ही मिनिमल कंट्रीब्यूशन हो इस ट्री का. 16 is a very huge contribution. Okay, because normally तो we talk about hundreds of trees in a ensemble model. अगर एक ही ट्री अगर 16 की वैल्यू ऐड करना चला गया तो यू कैन अंडरस्टैंड कि ये तो वैल्यू ब्लास्ट हो जाएगी, बहुत बड़ी हो जाएगी. तो उसको लिमिट करते हैं हम 0.1, 0.1, 0.1 ऐसे हर किसी का कंट्रीब्यूशन हम कर देते हैं, so as to come to an optimal value. Okay, सो लर्निंग रेट इसमें हम एज अ हाइपर पैरामीटर सेट करते हैं. एंड लर्निंग रेट का जो पीछे लॉस फंक्शन चल रहा है, यहाँ कॉस्ट फंक्शन, उस पर भी इम्पैक्ट होता है. ओके, हाउ द ग्रेडियंट डिसेंड इज हैपनिंग, राइट? बिकॉज नाम भी इसका ग्रेडियंट बूस्टिंग है. तो बूस्टिंग तो है, लेकिन ये अडेप्टिव बूस्टिंग नहीं है, ये ग्रेडियंट बूस्टिंग है. मतलब दिस बूस्टिंग डज नॉट यूज अडेप्टिव फीचर, रादर अ ग्रेडियंट फीचर. सो ग्रेडियंट एज इन there is a cost function or a loss function which will be going through some gradient descent process, and we talked about when you talk about gradient descent, learning rate plays a very important role, right? तो चीजें मैथमेटिकली कहीं जाकर वहीं फिट होती हैं जो बात हम पहले से करते आ रहे हैं, बट उनको यूज करने के तरीकों में थोड़ा फर्क आ गया है. ओके, so we are not setting any gradient, we are setting the learning rate. Okay, it's the learning rate. ग्रेडियंट की हम कहते हैं एक्चुअली ग्रेडियंट इज द डिफरेंशिएशन, एक्चुअली द स्लोप. ग्रेडियंट इज नॉट द लर्निंग रेट, ग्रेडियंट इज द स्लोप और द डिफरेंशिएशंस दैट वी डू. ओके, okay, so now what happens, guys, is once you have this new tree, now you have to build the next tree, right? Now our work is to build the next tree. So building the next tree, we need the new errors, then the new residuals, right? So how will we get the new residuals? Simple. You will see what both of these together will predict, not what only this will predict. क्योंकि अडेप्टिव बूस्टिंग में तो सिर्फ इस ट्री का ही इंपॉर्टेंस था, क्योंकि हर ट्री वहां पे वैल्यू प्रेडिक्ट कर रहा था. यहां पर ये ट्री वैल्यू नहीं, एरर प्रेडिक्ट कर रहा है. तो एक्चुअल जो आउटपुट आएगा वो तो इन दोनों के समेशन से आएगा, राइट? इन दोनों को आपस में ऐड करके आएगा. तो अब क्या होगा कि ये वाला जो पहला रिकॉर्ड है वो देखेंगे कि भैया जब पास होगा, जेंडर मेल था तो वो इधर आया, फेवरेट कलर ब्लू था तो वो यहां आया, हाइट यूज ही नहीं हुई इस केस में. ओके, 2 कॉलम के बेसिस पे वो यहां पर पहुंचा. तो इस बंदे के लिए 16.8 इस ट्री ने प्रिडिक्ट किया. उसको 0.1 से मल्टीप्लाई करो और 71 में ऐड कर दो, तो आपको प्रिडिक्शन मिल जाएगी कि इस रिकॉर्ड के लिए ये नया मेरा जो पूरा ट्री है ये क्या वैल्यू प्रिडिक्ट करता है. और उसको आप इसकी एक्चुअल वैल्यू में से सब्ट्रैक्ट कर दोगे तो आपको नया रेसिडुअल मिल जाएगा. तो अब हम नए रेसिडुअल्स निकालेंगे इस केस में. ओके, पहले केस में जब हम रेसिडुअल निकाल रहे थे हम सीधा 71.2 से सबको सब्ट्रैक्ट कर रहे थे. ओके, नाउ इस केस में नए रेसिडुअल्स 71.2 के साथ जो एडिशनल पार्ट ऐड हो गया है वो भी जुड़ जाएगा. तो आपकी वैल्यूज थोड़ी और अच्छी होती चली जा रही हैं. योर एरर्स आर actually decreasing, the residuals are decreasing. But now we will build the next tree which will further predict the next set of residuals, and this is how it will look like. The 71.2 multiplied by 0.1 times of this, यहाँ पर इसने ये लिखा नहीं है, multiplied by 0.1 times of this, सब में लर्निंग रेट मल्टीप्लाई तो चला जाएगा एंड फाइनल प्रेडिक्शन आपको आ जाएगी. ठीक है, बट यहां पर ये आपको सिर्फ ये दिखाने की कोशिश कर रहा है कि आपके रेसिडुअल्स कैसे डिक्रीज हो रहे हैं एज वी कीप इंक्रीजिंग द नंबर ऑफ ट्रीज इन द बूस्टिंग मॉडल. इनिशियली गाइस द रेसिडुअल्स वर 16.8 like this. You will see your residuals are decreasing, further decreasing. That means decreasing as I'm increasing more and more trees. So the number of trees is an important hyperparameter, right? Because more the trees, the lesser the error, but it does not mean you increase trees too much, because then there is a problem कि आपके पास उतनी computation power है या नहीं. It will take time. और ऐसा भी नहीं है कि आपने 1000 ट्री बोले हैं तो 1000 ही बनेंगे. मैंने कल भी बोला था, हो सकता है कि 100 ट्री के बाद फर्दर रेसिडुअल डिक्रीज ही नहीं हो रहे, तो मॉडल विल स्टॉप देयर. इट विल नॉट डू एनी फर्दर मेहनत. ओके, so now once you have the gradient boosting model completed, and this is a new record for which you have to do prediction, what you will do? You will have 71.2 plus 0.1 times of the error that comes from here, here and here. Okay, so you will traverse कि भैया हाइट, कलर, जेंडर के बेसिस पे मान लो यहाँ से कुछ वैल्यू आई, यहाँ से आप गए ये वाली वैल्यू मिली, यहाँ पे आप गए आपको ये वाली वैल्यू मिली मान लो, तो you will add, multiply 0.1 into this plus 0.1 into this residual plus 0.1 into this residual and so on to come up to the final value. Okay, so here there is nothing like majority voting or averaging anything. Here each tree is actually contributing in the final output. Okay, so that's about it. This is how the boosting model works, but definitely boosting model is having some problems, like it's a bit slow, plus it's not that accurate. So to solve that problem, there is XGBoost, extreme gradient boosting, which we will talk about tomorrow. You comprehend these first today, how the AdaBoost and GBM works. Tomorrow we will talk about how the XGBoost or the extreme gradient boosting works along with the other models. So let's implement this model, the AdaBoost and the GBM today. Okay, H2O is installed. You can have it. You have to install another package also, which is XGBoost. That you will use tomorrow. But if you want, you can put it on installation. It will take time. Okay, it's a heavy package. It will take time. sklearn does not have XGBoost. Okay, so today the lesson that we are going to do is for AdaBoost and GBM. But it does not have XGBoost. So XGBoost के लिए package install कर लेना. pip install XGBoost. It'll take some time. चार तो लगा के रख दो. Okay. So for me, it's saying requirement already satisfied. Okay, it's already there, available to me. And XGBoost further needs some additional libraries. It may not work on every Windows machine if those libraries are not there. Plus for Mac, there's some other nuances involved. Just try it. If you guys are able to successfully install it, it's fine. Otherwise, Google the problem that you will get and try to solve it before tomorrow's class if possible. Okay. And similarly, there are the categorical boost and light GBM. We'll talk about them tomorrow. So let me start the notebook. You guys can also start it meanwhile, and you can open the boosting notebooks from my GitHub account. No, don't do it on the mobile data for now because you are attending this session. After this session, you can try. And I already told you, right, the difference between AdaBoost and gradient boost. Completely, they are different in their approach. They ask you in an interview, you should know. And make sure you make your notebooks password protected. If you don't know how to do that, simple follow with me. Open the Anaconda. Open the Anaconda prompt. And just type in this command, Jupyter Notebook password. Okay. So that means in companies, normally your notebooks are password protected. Okay. So this is how this is done. You pass any password of your choice here. वो दिखेगा नहीं प्रिंट होता हुआ, प्रिंट हो जाएगा और वो पासवर्ड पीछे एक हैश फॉर्म में, हैश मतलब क्या होता है, सिक्योर फॉर्म में, एनक्रिप्टेड फॉर्म में इस फाइल में सेव हो जाएगा जुपिटर के फोल्डर में. देयर इज अ जुपिटर config.json फाइल. ओके, सो जस्ट पिंग मी गाइस इफ यू आर एबल टू डू दैट. और उसके बाद आपको नोटबुक दोबारा यहाँ से स्टार्ट करनी पड़ेगी. और पासवर्ड कभी भूल भी गए तो कोई टेंशन नहीं है, आप वापस से एक अकाउंट चला के वापस से पासवर्ड रीसेट कर सकते हो, पुराना पासवर्ड नहीं मांगता हो, क्योंकि आपके लोकल पे सेटअप है, कंपनी में आप नहीं कर सकते अपना पासवर्ड रीसेट, देयर इज अ सेपरेट टीम दैट डू दैट. So it will always ask you for this password, put it here and open it. So just ping guys once you are all are able to secure it through password. Okay, Gomini, thanks. Others? Okay. I'm just opening. I think there is no separate AdaBoost notebooks. So, but this Big Mart hackathon, if you can open this Big Mart hackathon GBM, you will be able to see that the GBM thing. I'm just trying to check. This Kaggle hackathon is there. Okay. So जब आपको डायरेक्टली ना मिले आप, क्योंकि हैकेथॉन्स में as we talked right, we normally use the complex models only. You can open this Big Mart hackathon GBM guys for the time being. Download it from my GitHub ना. इसको क्लोन करके रखो guys. Okay, I think आप में से कुछ लोगों को GitHub यूज करना नहीं आता. One second. Do this. First of all, follow along. Okay, follow with me. First of all, download GitHub for Windows or Mac, whatever you have. Do it. So you can go to this downloads. You can download from here, say for Windows, you have this download links, right? You can download it from for Windows 32, 64-bit, whichever you have. Download it, okay? Perfect, perfect. Those who have downloaded it, it's good. So once you guys have downloaded it, come on to this place and type. You don't even need to type anything, leave it. You go to any place on your system. Go to any place on your system. Create an empty folder. Go onto your system. Create an empty folder. Give it a name, anything. Maybe say notebooks, whatever. Open it. Any name you can give in it. Right click and click on this git bash. जब आप वो git tool download कर लो नेट से, ठीक है, नेट से git tool download करने के बाद उसको इंस्टॉल करना होगा आपको उस exe फाइल को रन करके. जब वो कर लोगे तो किसी भी फोल्डर में जब आप जाओगे राइट क्लिक करने पे git bash आएगा. git bash पे क्लिक करो. तो प्रोवाइडेड आप लोगों ने गिट डाउनलोड कर लिया है, इंस्टॉल भी कर लिया है, किसी भी फोल्डर में जाओ, राइट क्लिक करो, गिट बैश ओपन करो. जब गिट बैश ओपन हो जाएगा, यहाँ आपको एक सिंपल सी कमांड चलानी है विच इज गिट क्लोन. ओके, और उस रेपो का एड्रेस देना है जिसको क्लोन करना है. तो वो एड्रेस कहाँ से मिलेगा? गो टू इंटरनेट, ओपन माई गिटहब अकाउंट. Data science with Python. So go inside this, and here there will be a cloning path. What happens? Yeah, click on this code. You have this path right here. Copy this path. In the drop down, you will have, or Even it's telling you the command also, but leave that. Just copy this, paste that path here. So you're cloning my entire repo, my entire Git repo. I'm not just doing it, and press enter, or let me do it, that's fine. It's downloading everything on your local machine, okay? So it will download everything here in this folder, see. So this is from the GitHub, and it's further downloading the stuff. So please follow along, guys, and confirm me once it's done. Once you have cloned the entire Git repo. So it's doing it right now. No problem, but make sure once you have the Git installed, you do the git clone, जिससे आपको बाद में इंटरनेट की जरूरत ही ना पड़े. ओके, सो ये क्लोन हो गया है, तो मेरे लोकल पे सब कुछ आ गया है. ओके, एवरीथिंग इज ऑन माय लोकल मशीन गाइस, इनसाइड दैट नोटबुक्स फोल्डर. तो आप सीधा यहीं से पढ़ सकते हो. यहीं पे नोटबुक्स हैं, इन सबको यहाँ से अपने जुपिटर में ओपन कर सकते हो. ठीक है, यू कैन डू एनी. जुपिटर में वो पाथ सेट करके आप यहाँ से कोई भी चीज एक्सेस कर सकते हो. ओके, बट कंसिडर अ सिनेरियो. आपने आज तो क्लोन कर लिया था, लेकिन कल मैंने कुछ नई नोटबुक्स डाल दी वहां पे, या पुरानी के अंदर कोई चेंज कर दिया, तो आपको दोबारा बार बार क्लोन नहीं करना. जस्ट डू git pull. यू आर पुलिंग द लेटेस्ट चेंजेस फ्रॉम द GitHub. अच्छा, इसके अंदर जाना पड़ेगा. So I'm doing the git pull. So it will tell you that it's already up to date. Okay, I push the data, you pull the data. Okay, I push it, you pull it. That's it. You don't need to push. Okay, because if you start to push and I also push, merge conflicts will happen. The conflicts will start to happen. I mean, I haven't given rights to any one of you anyways to push to it, but that's the problem. If multiple people start pushing, the conflicts start to happen. So this is Git. Okay, this is most important thing when you work in a company. Okay, it's the most important thing to work in a company. So you keep pulling it, say every day after the class, like every day after the class, like half an hour after the class, you run a git pull, because I take 30 minutes to at least upload the things. I change few things and all. So you can pull it so that you have always the latest code. And it also tells you what files you have pulled, so that you can directly open those files. Okay. Yeah, Rahul. So I hope I answered your question, right, Rahul? Means it will not automatically clone it. You have to always do git pull, right? Means वो refresh नहीं करता बार बार, आपको खुद से उसको git pull करना है. आपके लोकल पे हमेशा चीजें अपडेट होती रहेगी. So Pravisha, I think that answered your question also, right? You don't need to fork it again and again or clone it again and again. Otherwise, so you will keep creating copies. You will simply pull it. Just keep pulling it. You don't need to consider about PRs, pull request and all, because that's a different thing. When you want to merge the code into my repo, then the PRs and all happens. But Prakash, are you clear? You don't need to raise any pull request and all. If any one of you wants to contribute back to my repo, you have to push. And that's where the Prakash's point is, like, you have to raise a PR, but then I will see and I will approve or reject it. So you can push your own notebooks to my repo by running your, say तुमने कोई नई notebook बनाई और तुमने उसको git push किया, मतलब उसकी पूरी कमांड होती है, आई एम नॉट गोइंग इनटू दैट, तो वो मेरे पास एक PR बन के आएगा, यू हैव टू रेज अ PR एक्चुअली, पुल रिक्वेस्ट, मैं फिर देखूंगा मुझे वो अप्रूव करनी है या नहीं. So I will come here, this is the PR pull request. So if you are trying to contribute, वो नाम थोड़ा confusing लगता है कि नाम है pull लेकिन आप कर रहे हो push, don't worry about that. It's like you want me to pull your changes at my end, so do I really want it or not, right? So it's like that. So I approve it or reject it. It's just when you want to make changes in my repo. So here I'll see all those people who contributed or want to contribute. Okay. Nishtha, yeah, what's the question? Okay. Which side channel features? So see, there are some good websites. I'll tell you. Just see this. There is this data science mastery. Not this. 1 second. Just check if you can see data science mastery. That's one good website. Data science mastery. It's good. So yeah. So these are the towards data science, guys. Towards data science, it's good. The machine learning mastery, this is a good website. Go through these two. I think these are more than enough. यहाँ पर आपको बहुत अच्छा कंटेंट मिलेगा, बहुत डिटेल्ड मिलेगा. And then there is this thing towards data science. This one is also good, towards data science. So you can search for the topic of your interest on data science and machine learning. Okay, so just go through these. These are good. I have pinged you. Towards data science and the machine learning mastery are the good ones. There are few more which I'll tell you later. Like medium.com, right? So there is this thing medium.com. So sometimes there are good articles on medium.com. So sometimes there are good articles on medium.com, you can go through them. But it's a very generic website. It's not only for data science, it's a very generic site. Okay. So we'll take a break after 3 minutes. Just give me some time. There are some good YouTube channels also, like Joss Stammer, StatQuest. There is one more which is quite good. I will ping you. And then there are some Stanford University channels that you can follow. Also, Coursera is a good place to start if you have to study about mathematics behind data science. So this guy Andrew Ng had a course, but it's only for those who wants to go into the maths behind it. Okay. Otherwise, it will be a complicated thing. Yeah. So this Andrew Ng stuff is good. I'll ping you one course. So this thing, the machine learning one. This is good actually. This is free. For certification you have to pay, but this is free. But it's very mathematical. Okay. If you are interested, you can go through it. It's very mathematical. Okay. Okay, I think these notebooks are not opening. Oh, 1 minute. So guys, let's take a break. Meanwhile, I think these notebooks are okay. Okay, wait 1 minute. So give me 1 minute. Okay, it opened. If it's not there, leave it. 1 second. Go inside this hackathon thing. Okay, it's not there in the hackathon. Let me check. See hackathon. Okay, so for the time being, you can just wait for it. After the class, I will put it there so that you guys can have it. So I think I have done. Let's see. Okay. So once we are back after the class, we will talk about this notebook. I'll explain you what's happening here. Okay. And then I'll upload it after the class. So we will talk about ADA Boost and GBM, guys. So we'll connect at 12 o'clock after 15 minutes. statistics we will start in the next week. Okay. So first I will complete all the models like time series model and all. Next week we will start with the statistics. The few tests that you guys requested, I have a list of those, chi-square and t-test. I'll tell that, and then we will start neural networks. Okay. Okay. So 1 second. What's the question? There are some questions. So Gulzar means, yeah, transactions are less, but amount is generally more. Means you cannot say that because hackers, normally those who hacks your cards, they first try some transactions with lower amounts and then they transact with a higher amount. So it depends. Sometimes hackers don't want to immediately use it for a higher transaction. So it's all depends on the data set. They do small transactions like of lesser amounts so that they are not getting caught. That also happens. So hackers are also quite smart. Okay, anyways, I'm fine with this. Okay, so let's stick to this. This is the data that I have. Let me drop a column from here. I'm dropping the time column. Say I don't need it. So time is not found in the axis. So what I have to do, I have to say axis is equal to 1. So guys, you should know, okay, what the error is. Column time is not found in the axis, right? So that means axis 0 or 1, where we need to look at, right? So it's a column, so I need to drop it like this. So it's df1. So that column is dropped, okay. So I've created this data frame, drop this column. Now I have the data. So what I can do is I can further have my x which simply says drop the target. So target column is the class column. We can check for it. So it's the class column, okay. So I'm dropping the class column, and for the y, I'll simply there are multiple strategies, okay, to split your data. So it's not like there is one thing only. So I splitted my data into say x and y, which is further needs to be divided into train and test. So I divided, first of all, I remove the unnecessary columns like time. It's just because I know it's not needed, I'm dropping it, but it's not like that it's not important. I'm just dropping it just to show you how to drop a column. Okay, it's not like that this is not important. So just to show you, I'm just dropping one of the column which is not needed. Then I'm taking all the features by dropping the class, and then I'm taking only the target. Further, I can split this data into 30-40 or like this 70-30, 80-20 ratios. Okay, that's another thing. So currently I have my x and y. So don't get confused, guys, that I'm not splitting it. I am not splitting it because I just want to, I'm taking the entire data for training, okay? Because I want to show you the implementation first. So now we have the data, say x and the y. We can split it further later, but I'm taking entire data for training. Now I am importing the model, sklearn dot, and so from sklearn dot ensemble, I'm saying let's import what? Okay, import AdaBoost classifier. it's just coming up. Okay, I've pressed in the type. Okay, so you have both AdaBoost regressor and AdaBoost classifier. So I'm taking the AdaBoost classifier here. Similarly, you have GBM, right? So you have gradient boosting classifier in the regression. So we will use these two. So let's first use the AdaBoost. Okay, so Ada is this thing, and I am showing you Ada. Okay, so this opened me the first boosting algorithm, which is the AdaBoost algorithm. And in the AdaBoost, we know that all the models are like sequential, and they are like have some importance. Each tree has its own importance. So the first hyperparameter is the base estimator. So in AdaBoost, if you want, you can use a model other than decision tree as the base model, but by default it uses decision tree. If you want, you can use another, as we talked about grid bagging yesterday, right? So the same thing can be done here also. Number of base models that you want. Learning rate, here we prefer to keep it as 1. Don't change it much. Keep it 1. Algorithm. This is something which is the actual important part here, where SAMI and SEMI are the two important models. The actual algorithm, okay, the mathematical formula that runs. SAMI is the old one. SAMI-R is the more optimized version of the SAMI. So the SAMI-R is an optimized version of SAMI, which trains faster, converges faster, like towards the global minima. If I say it's faster, it leads to lesser error in the model. Primarily during testing, the test errors will be lesser in this as compared to this. So prefer using SAMI-R instead of SAMI. Yeah, Vipul, that's what you can use another also. Like you want, you can use. There are a few things that you need to remember. Okay, first of all, if you are doing regression, then these should be the regression models. If you are doing AdaBoost classifier, then this should be the classification models. The second point is not all classification models can be used. Means it all depends whether AdaBoost supported or not. So you have to go through that documentation. But even without going through the documentation, you can simply put in support vector classifier here, the logistic regression. They will work. But I'm saying KNN, for example, right? KNN, I'm not sure will work because it's has its own different way of working, right? It's a memory-based model, right? It don't uses any gradient or convergence. So because that model should also have some kind of statistical correlation with boosting. Okay, you can definitely use different estimators, but some of them might not work just because of the internal working of that model. Like naive-Bayes or KNN, I am doubtful, but logistic regression, support vector classifier, decision tree, all those you can use. Okay. Okay. So so you are doing classification by a meta model, and that meta model internally learns decision tree. So internally, the one that we are going to run is going to run a decision tree, multiple decision trees internally. Okay. So if you see SAMI-R, that converges faster. It's that what it's do. Random state, again, just for setting the seed, because internal the data shuffling happens, right? And this SAMI-R, you can consider it like the model which is actually doing that both the data shuffling for you based on the weight importance plus all that mathematics which is running behind, right? The amount of say and all those which is happening. So everything which is getting calculated is because of this actual implementation. There are not much parameters associated to this, but
let's see the next one, which is the gradient boosting classifier. Here you have more things to play with. So we know how GBM works, right? GBM is like an additive, it's an additive model. Additive model means first model, second model, third model, all are adding up to give the final prediction. It's an additive model, okay? पहले ने कुछ प्रेडिक्ट किया, दूसरे ने, तीसरे ने, चौथे ने, तो चीजें ऐड होती चली जाती हैं to give you the final result, okay? So GB builds an additive model, okay? So it's written, it's an additive model in a forward stage-wise fashion. And I told you there will be a loss function or a cost function. So we are trying to optimize that here. But this optimization function is specific to the model, the hyper or the meta model. But internally, if you use, say, a support vector classifier, it will have its own optimization. So you will run two optimizations, one at the base model level, one at the meta model level. Okay. So here a few things which are important to remember is ultimately what's happening is the internal model. See, even more important are the internal models, right? How the internal models are working. Because external model to at the end of the day, uske zyada kuch hyperparameters hai hi nahi. Learning rate is one of the hyperparameters that we saw for gradient boosting and the number of trees. But internally what happens is actually this loss, the loss function or the cost function which I was talking about. So if you are implementing a regression model, if you are trying to use gradient boosting for regression, you will use a deviance or the deviance, which is like I told you, right? LSD, least square deviance, even while building the trees, right? And for logistic regression, like in classification, if you are doing classification, then it's similar to logistic regression. So gradient boosting model को अगर आप regression के लिए use करते हो, it's like minimizing the square deviance or the squared error, you can say, to be very simple. It's the SSE, squared sum of errors. But if it's logistic regression, it's that logit function, the log of odds, right? So it uses the log of odds function. Okay, so logistic regression के लिए वो log of odds function को use करेगा, और हमने logistic regression में बात की थी. Exponential you don't use because exponential will somehow behave like ADA boost model. So if you pass on this value as exponential, it is something like ADA boost. So you don't use it. We use deviance, and deviance देखते ही model internally समझ जाता है कि अगर regression है तो minimizing the square deviance, और अगर classification है तो it uses logistic regression, which is the log of odds. Learning rate here very important, as I talked, right? It should be somewhere between 0.1 0.2. Okay, जबकि ADA boost में I told you keep it 1, but here you keep it 0.1 0.2 because of the things we discussed. Number of estimators, yeah, it's important. Subsample is like, again, as I told you here, as I told you, right? While building a new tree, how many records you want from the original data? Do you want all the data, or you want a subsample of the original data? So that's what subsampling is. While building any tree, how many records from the original data you want? This criteria, guys, is what actually decides your split. So if you look here, in gradient boosting, what you are doing is you are always having numerical target, right? It's a numerical target, and you are trying to build this tree on top of it. So what you want is this is like a regression tree, right? This is not a classification tree. And if it's a regression tree, I told you we use MSC. And if it's a classification tree, we use Gini, right? If you are building a regression tree, we use minimum MSC, right? Minimum squared error. If it's Gini classification, we use Gini. So here our target is to predict the weight, or rather even the residual, right? So we don't use Gini here, it's MSC. Okay, so that's what this thing, MSC, MAE, or even the Friedman MSC, which is optimized MSC. So this criteria is actually the criteria for building the trees. This is for the data which is going inside each and every tree. This is the estimators number of trees. This learning rate here is just a parameter which is getting multiplied to the output of each tree. And this loss function is actually the cost function that we are using overall at the model level to do the minimization of the cost function. We do the gradient descent kind of a process. So these are all the properties. Other properties are related to decision tree, min sample, min split, min bucket, and all. Random state, max features, all these things which we talked about, right? But the question is, there is one question that I think none of you have noticed. Let me tell you that. I showed you gradient boosting classifier, not the regressor. And no one, I think, pointed it out, then why we are using MSC, right? Let me tell you the difference. If you see this, the criteria which is for the internal trees, जो internal trees हैं वो किस तरह से स्प्लिट हो रहे हैं, चाहे वो रिग्रेजर हो तो भी वो MSC है, मतलब गिनी नहीं है. अगर वो क्लासिफिकेशन है तो भी वो, what happened? Okay, so it's classifier. So in that case also it's Friedman MSC, right? It's not Gini. Here we are not talking about Gini. So what's the reason behind it? Let me tell you. So what we do, guys, मैंने आप लोगों को रिग्रेशन का एग्जांपल समझाया था, so that जब मैं आपको क्लासिफिकेशन के बारे में बताऊं, it will be easy. Say instead of predicting the regression, the weight, you want to predict I'm telling you. So instead of weight, if you have to predict something like target class Y or N, yeah, that's what I'm explaining, Nishta. That's what. So what happens, guys, here is if you're predicting whether someone is is obese or not, based on this data, whether he's obese or not, right? So here the first node that gets created for classification, what it do is it calculate probabilities. So probability of positive class, say P for obese is what? How many? Yes, 1, 2, 3, and 4. 4 out of 6, right? And 2 out of 6 is the negative class, right? So here here, like what we have is the logit function. So the model here, the boosting model, does not predicts the probability of obese or not. It rather calculates that logit function. You remember we were talking about sigmoid curve for classification, and here it was like probability between 0 to 1, and to convert it we have to do the logit function so that we get a linear curve, so that on this linear curve we can apply the gradient descent, right? So ultimately our purpose was to use a logit function, right? So here what we do, we actually instead of predicting the class, we calculate the logit value. So the logit value formula was what? Log of odds, right? It was log of odds. Log of odds, as in here it will be log of 4 by 2, right? Initially, if I just look at this data, or if I have only this column, then the log of odds is log of p upon 1 minus p, right? So, or you can say log of favorable events upon unfavorable events. So 4 by 6 upon 2 by 6, 6 cancel ho jayega. It's like 4 by 2, right? So log of 4 by 2 will be some value that will be coming here, the logit value, right? So here, what model predicts is, model predicts a logit value, okay, at every step. So logit is a numerical value, right? So here your model is actually getting converted into a numerical prediction problem. And once you have a logit value, you can apply, and once you predict the logit value, you simply have to apply the sigmoid function on top of it to get the actual probability, right? So 1 upon 1, I think 1 upon 1 plus e to the power minus of z, right? So this z will be nothing but this logit value. If you put this logit value here, you will get the probability, and the probability may be say 0.5, 0.6, 0.7, whatever. So here the models which are getting built are actually not predicting the sigmoid values, rather they are predicting the logit values. Internally, model uses the sigmoid function to give you the probability, but understand it that the model at every step when getting built is actually giving you the logit values, okay? And the first model will capture the logit value, the rest will start capturing the residuals or the errors here also. So you can go through the actual more concepts about it, how the GBM works for classification, but if you know how it works for regression, and if you remember this concept which I just told you, that we are using the logit function, you can remember it, because here also at each step the trees are using the residuals in the logit values to build the subsequent trees. Okay, so that's what the point is. Whether it's gradient boosting regressor or gradient boosting classifier, the trees which are built are based on the numerical values, which are the logit values or the errors. Okay, so that's important.
Yeah, good question, Vipul. So definitely it works the same way, but the point is then you have to also change your base model a bit, like the parameter OVO and OVR, right? That so you have to set a OVO or OVR. So the base model, if does not have that properties, then you have to create your own base model. So here, if I look at nowhere OVO OVR thing is being asked, right? So what you can do, you can create your own base model and use it. Okay, try to use it. But if you look at the interesting thing is GBM is actually a tree model. Okay, GBM is a tree model only. It is not allowing you even to use any model other than decision tree. GBMs and XGBoost are only tree models. It's the ADA boost that allows you to change the models. So, and as I told you, OVO and OVR we do only in the case of logistic and S support vector machine. So that can now you can only do that in the ADA boost only. Okay. So ADA boost is the one which only allows you to give a custom base model. Okay. Here you have this base parameter, right? So ADA boost allows you, but gradient boosting, extreme gradient boosting, all these are actually the tree based models. So you cannot change the base model here. Okay. Because of the mathematics which is involved, but ADA boost is something different, right? Because here you are just averaging the sum at the end of the day, so it allows you. No, that's not stacking. No, that's not stacking. No, Nishtha. Stacking means you are using multiple models simultaneously. But if I am talking about ADA boost using 10 support vector machines, then still all the base models are support vector machines, right? So it's not stacking. Stacking is when you have mixture of the models. 5, 3, 5 support stacking is. Okay. Bagging boosting is not allowing heterogeneous models. It only homogeneous models. So everything that we are doing is homogeneous models. Stacking is something which is heterogeneous. Okay. Okay. So Gulzar, it's fine. Means if you have questions, it's you can ask me individually and in group also. That's fine. Okay. So let's see. Just run it quickly and. So now, once you have the data, you clean the data, remove the columns, split it into train test, scaled it. Then you simply need to look at the model first, look at its hyperparameters, and put those values in and just run the model, the fit part of it. And once you fit it, then you should not immediately jump into predicting. Once you fit the model, just check for the train errors, the train score, check for what the model has learned, check for those internal parameters,
or the slopes if it's a linear regression, or the centroids if it's a k-means. So go through all those things. Now if you see, this model is running because my data is too huge, at least like I think 4 lakh records, and on 4 lakh records this model is further running 10 parallel models, so it will take time, right? I could have done this thing, at least verbose is equal to true. So the models are getting trained, और जब भी आप ensemble model learn करो तो internal हर एक जो model चला उस internal each model ने क्या data लिया था train होने के लिए, all that can be done. So print all the trees if possible. It's taking too much time. So what I'll do, in the interest of time, I'll run this on the smaller data set, guys. Okay. I'll run it. It's like keyboard interrupt. Let me take some data which is already available to me. Which one? So that's where the for 10 hours, 20 hours, they keep running. Needed. Okay. So I'm creating it with the name boosting. Here. So we are using ADA boost classifier, and let me just run this. So again, I'm back to the wine data for the time being, where we are predicting the category of the wine based on the features. Okay. I'm not plotting these graphs. I'm quickly coming into the train test split. Okay. Okay, so verbose is not available here. Let me just check it once. Ideally, ensemble models should provide any complex model should provide verbose. Otherwise, it's difficult to see what's happening at the back end. So this model does not provide it. Okay. So I'm not using that. Let me check this. Yeah, we have verbose. So guys, if you see here, okay, this was quite fast because we had very less data. But if you see what happened here is this model internally went through 100 iterations. So 1 second, just see this. So default number of estimators here are 100. Okay, so that means the model is running 100 cycles internally to reach out to the best possible value. So 100 iterations are happening here, right? The first iteration only one tree. Second iteration you will get another tree added to it. Third iteration it will add another tree. Fourth iteration it will add another tree. And with the addition of each tree, is my total loss going down? This is the total loss. See, each tree will be built based on the Guinea or the MSC, right? So each tree has its own criteria of splitting, but at the total level, we use the loss function. That total, what is the loss function and is it decreasing? Which is again the deviance or the logit function or maybe any other function. So if you see here, 100 trees and 100 iterations, with each iteration the loss is going down. Sorry. The loss is going down, so that's where the model is good. Let me increase the number of estimators to say 1000. So this is running, okay, 400, 500. But if you look at this output, you can see that if you would have stopped, right, there is no benefit of further going after 80, 90. Okay, so this is what your model did, and it showed you that the optimal number of trees for this given data, okay, not for the other data, for this given data would have been 80. That's what the benefit of verbose, okay. So verbose equal to true हमेशा रखना, और तो नंबर ऑफ एस्टिमेटर्स अननेसेसरली बढ़ाने का आपको कोई फायदा नहीं है. आप 100 भी रखो, इसको 80 भी कर सकते हो. That's fine, but now let's see what is the accuracy of this model. I'm just checking the train accuracy. 100% again, maybe a misleading thing because it's very less data. Let me run add a boost also, because यहाँ less data है हमारे पास, तो कोई problem नहीं है. Add a boost is good. So add a boost is done. Let me check its accuracy. So it's 96, so quite good. Add a boost is good, quite better. Okay, so here also we ran 80 trees, but those 80 trees, one minute, this thing, this print time, So guys, what I'm trying to show you here is how much time that model, because ये verbose मुझे दे नहीं रहा, तो I'm just trying to do certain things here. कि AdaBoost model जब मैं run कर रहा हूँ, तो AdaBoost model internally parallel तो नहीं, sequentially बहुत सारी trees बनाएगा, 80 trees बनाएगा, तो total time कितना उसको लग रहा है in building those trees. So I'm just printing the start time and then end time. So it took very less time, like around 0.5 seconds. So just this is what you can check how much time your model took to train. Similarly here, if I check, model took almost similar amount of time. You can say start time, or you can say this is your end time, and you can simply subtract the two. Yeah, this is milliseconds. So here it took 83 milliseconds. Sorry, matlab 0.83 seconds something. Once. And same thing you can do here also. So this is what you can check here, how much time it took. So you can just check what it is. This is the time that happened since the epoch. So you guys can read about something known as epoch time. What is epoch time? So इतने seconds और इतने milliseconds कब से अब तक milliseconds, microseconds. So ये epoch time is important in the field of machine learning. You should know time, what is epoch time, and you can simply subtract and check these values. Okay. So guys, before we go to the next topic, so today we talked about boosting. We talked about. I'll tell you, Gulzar, one second. We discussed about the AdaBoost and the gradient boost, and also how gradient boosting model is different in case of regression and classification. The only difference is that logit function is being used instead of telling you the actual predictions. But gradient boosting is first of all a tree-based model. You cannot use another base models, and there is this learning rate which is important there. Okay, and it builds regression trees. Okay, because it's predicting the residuals, even in the case of classification also. But residuals by using the logit values को subtract करके वो आपको बता देगा. Okay, and then we implemented this, the AdaBoost and the GBM. We saw the hyperparameters कैसा क्या मतलब है, and what all the iterations, verbose, why it's important, how to check how much time your model took for training. So 0.83, it's like 0.83 seconds, not even 1 second. So you will read it like 0.83 seconds or some 833 maybe microseconds, whatever. Okay, and each iteration is known as an epoch also in machine learning. But here the epoch that I am talking about is not that. In machine learning normally हम iterations या epochs की बात करते हैं, but ये epoch time जो है ये अलग चीज है. जैसे आप लोगों ने ल्यूनर कैलेंडर सुना होगा, राइट? ल्यूनर कैलेंडर, you have Gregorian calendar. So you guys as a data scientist should be aware about data, right? So you should know what is lunar calendar, or what is Gregorian calendar. Okay, so this is when it comes to calendars, right? But when it comes to time, time is also in different formats. You talk about time in the format of DD, MM, YY, YY. This is one of the format, right? There are other time formats. Similarly, epoch is a time format, guys. It's a format, nothing else. So when someone say this date is in the epoch format, then that epoch format is what? 1st January 1990, I think. देख लेना. 1st जनवरी 1990 को मान लो एक घड़ी स्टार्ट की गई थी जो आज तक चल रही है. ठीक है, तब से आज तक कितने सेकंड बीत चुके हैं? निष्ठा सेइंग 1970. ओके, हाँ, मतलब ये ऐसा कुछ रटने वाली चीज नहीं है. तो 19, थैंक्स निष्ठा, थैंक्स. सो 1st जनवरी 1970 को एक घड़ी स्टार्ट की गई थी. तब से आज तक जो भी टाइम बीत रहा है वो उसको हम इपॉक टाइम कहते हैं इन द टर्म्स ऑफ सेकेंड्स. ओके, तो अगर मैं यहाँ पर randomly let me just print some time. So this is the epoch time. Now let me print it again after some time. Wait, see now. So अभी आप देखोगे तो जितनी देर में ये दोनों फंक्शन मैंने रन किए, टोटल कितना टाइम सेकंड्स में बीत चुका है, राइट? तो ये कितने सेकंड्स है? 1 जनवरी 1970 से लेकर आज तक कितना सेकंड्स बीत चुके हैं, और ये उसका मतलब फ्रैक्शनल पार्ट है. डोंट से इट मिली सेकंड, माइक्रो सेकंड, डोंट टॉक इन दैट टर्म्स प्लीज हियर, एट लीस्ट इन epoch. This is the fractional part, so you can subtract these to get the fractional part. And there are online converters also. See, so this world is quite bigger, means machine learning से बाहर भी बहुत चीजें हैं, which you guys should be aware about as a data scientist. Different data formats, date formats, calendar formats, maths और stats तो है ही है, which I was talking about. So you can have this epoch converter, and if you put any epoch date here, guys, and you want to see कि ये epoch date, Gulzar, you can read about that, the relevance of it. Okay, so that serves as an industrial as a standard in the field of statistical computation. Then we have a common point of reference. For example, we have Greenwich Meridian Time, right? GMT. So GMT is serving as a central time for all the countries. You say I'm GMT plus or GMT minus, right? So that's a reference. So there might be some reason these guys have decided it. I'm not aware about it. But this is the reference which we use for statistical computations. So if you put any given epoch time in this format, you can tell when that event happened. Okay, but I can definitely tell you the benefit of epoch. The benefit of epoch is it's giving you a decimal value. So say for example, if you have to do operations on dates, it takes time. But if you do operations on epoch, it is fast. For example, if you have a time column on which you have to do some say prediction, for example, using that column, it's better you convert it into epoch because it will not lose its relevance, but will be faster. And second is, if you have dates, increasing dates or decreasing dates may not have some correlation in maths, if I talk mathematically, for a say formula. But if I convert that date into a number which is either increasing or decreasing by the increasing decreasing days, and now if I want to do some derivation, differentiation or integral calculus, then that number definitely tells me that with the increasing number what's happening. Okay, So there are a lot of things that the epoch helps us to achieve faster computation, somewhere in prediction analytics. Okay, so that's where we have the benefit of not using DDMMYY, rather use a number to represent that DDMMYY. Okay, does that help?
सर एक मिनट, पर इस कोर्स में ये बेहतर कैसे है डेट फॉर्मेट से? इस कोर्स में
ये बेहतर कैसे है डेट फॉर्मेट?
डेट फॉर्मेट से कैसे?
So Gulzar, see, it's not like you from only this source of point everything. That will be very limited. Okay? You have to be very widespread, right? Because say tomorrow what happens is, okay, इस कोर्स की पॉइंट ऑफ व्यू से समझते हैं. अगर कल को मैं आपको डेटा भेजता हूँ जिस डेटा पे आपको कुछ एनालिटिक्स करना है और उसमें डेट कॉलम में epochs हैं, but you want to use DDMMYY, let's take it that way. But if you don't know what is epoch, how will you convert it into DDMMYY, right? So consider it that way. So if someone is sending you a column with epoch values and you don't know what is epoch, you won't be able to convert it into DDMMYY, right? So that if you want to do analysis on DDMMYY format, so take it from that point of view. Or say I give you a epoch and you have to do time series analysis on that data so that you can see what's happening on every weekends or weekdays, whether your sale is increasing on every weekend or weekday, it will not tell you, right? So first from epoch, you will convert it into DDMMYY format. Then using the day, you will check whether it's a weekday or weekend, and then you will see whether your sales are increasing on a weekend or a weekday, or whether sales are increasing on a particular month, like Christmas, Diwali, like that. So if you have to do time series analysis, you may need to convert epoch into this format. Okay, so there are a lot of such concepts that comes handy. Okay, absolutely. So if you can see my screen, right? So there are Python programs that can convert an epoch directly into this format using Python packages to fetch date, month, year, whatever you want out of it. Okay. Varsha, that no, Varsha, that epoch is different. The epoch in neural networks is nothing but the iterations. Okay, Varsha. This epoch is the epoch time, the date format. That epoch is the number of iterations that you want to run. Okay, Varsha, is that clear? You are right that epoch is a hyperparameter in neural network, but that epoch is iterations. That epoch is not the epoch date. हाँ Varsha, okay, good. Yeah, you remember it correct. But that epoch is different from this epoch. Okay, here it's not there. Yeah, so here it is, right? Kaggle's ones. सो बस इसके अंदर आपको नाइव बायस या जो भी लग रहा होगा उसकी जगह पे अपने फंक्शंस लगाने होंगे। मैं ये नोटबुक भी डाल दूंगा वहां पे अभी थोड़ी देर में। वैसे भी ये तो मैंने किल ही कर दिया था। ओके, ये बिग मार्ट वाला भी रहने दो, इसको हम किसी और केस में उठा लेंगे, बिग मार्ट वाले को। सो यू कैन यूज दिस Kaggle one, and I'll put this boosting one also. So there is boosting and the Kaggle, you will get these two. I'll put this. Okay. Now, yeah. So now there is one topic which I want to start today. We will take another 15-20 minutes before we end the class. So read more about AdaBoost and GBM. Tomorrow we will talk about XGBoost and other models. Pip install the XGBoost before tomorrow's class. The XGBoost. Okay. Okay, so with that, we are now moving into the next topic, which is very important, and that is time series analysis. So today I'll just give you a brief about time series analysis. Okay, तो देखो अभी तक guys, whatever we were talking about was supervised machine learning. Okay, and in supervised machine learning, we were talking about regression and classification. And further in classification, we talked about bagging, boosting. Further in boosting, we talked about AdaBoost, which can allow multiple base models. GBM, which only allows trees as the base model. And then the XGBoost, Light GBM, and CAD Boost. Okay. So we will talk about that tomorrow, the remaining ones. But after this comes another field of supervised machine learning. This is also supervised machine learning. Okay. But it's different. Series forecasting. So time series forecasting is also a supervised machine learning, because in this also you have the features and the target, but the way it works is completely different, because here the features are not actually the features that you talk about कि उसकी age कितनी है, उसके पास गाड़ी है, बंगला है, मोबाइल है, नहीं है, all those things, right? Here the feature is only time. Time is the important feature. Based on time, we do all the predictions. Okay. So in the time series analysis, let me take about okay. So in the time series analysis, guys, what happens is there are cases जब आपको time series analysis use कब करना होता है? Definitely when your data contains say only two columns, one is the time column, another is what you have to predict. That's one of the case. Another case is when you have to see the impact of time on the output. For example, your sales, right? So in the field of time series, actually it's two-part thing, analysis and forecasting. So like in normal data, you do feature engineering and then prediction. So here also we do feature engineering and prediction. So the feature engineering part is time series analysis and prediction is forecasting. कल कितनी बारिश होगी, क्या जनवरी के मंथ में अगले साल मेरी सेल बढ़ेगी या घटेगी, राइट? या फिर आज के दिन में मेरे कॉल सेंटर में कितने कॉल्स आएंगे, All that is like time series analysis. Okay. So if you look at time series data normally is, say Walmart or Netflix want to predict how many customers are going to add on to their system in the next few months, right? So means when time is the parameter, okay, so time as a base parameter is actually helping you to do any predictions. So time is most important. Whereas in normal machine learning, we don't give that importance to time column, right? So that's where time series forecasting is important. Okay, time series forecasting can be used to forecast the traffic that will be there at a particular city, place, toll bridge. Okay, so that government can better manage the traffic. They can add more routes. For example, during which time of the day there is more traffic. For example, जो लोग दिल्ली में है, they know कि in the evenings there is too much traffic from say Noida to Gurgaon, Gurgaon to Noida. So during that 2 hours, 3 hour slot, can government make some paths single, like one way, some two way, depending how they can manage the better traffic, right? So all those kind of things can be done. Okay, Google Map, I'll not talk here. It's a different concept altogether. But consider that Uber and Ola, right? How they know that when to have search prices, right? When they know that there is a lot of demand that is coming, they do search pricing, right? If they already know that during this time of the day we are going to get more demand, they should not put search, rather they should put more drivers there, which will help both customer as well as Ola, Uber, right? Because no one want to pay search prices, right? तो अगर ओला उबर पहले से पता लगा ले कि इस टाइम पे मेरी डिमांड इस एरिया में ज्यादा होने वाली है, वहां ज्यादा अपने ऊपर ओला ड्राइवर्स को डिसाइड कर दो, उनको इन्फॉर्म कर दो, सो दैट सर्च प्राइसेस की प्रॉब्लम से सब बच जाए. You can improve the customer experience, right? So Google Map plays a role in a different way. It's in the traffic analysis, but in a different way. Yeah, definitely. That's what I'm saying, Guljar, that search pricing is not good, right? So how can companies avoid it? By making sure that more availability of the cabs are there. So they can do time series analysis and avoid these kind of problems. Similarly, those of you who may be interested in stock price, right? So that's the best field the people use is stock price predictions, right? Bitcoin price, cryptocurrency price predictions, and all, right? Similarly, passenger predictions, right? Say for example, the airlines are there, and airlines identify that the passengers are going to be less in a particular month. Then they can put some offers accordingly to increase the passengers, right? Or if say hotels already know that more passengers are going to come in a particular month, then they can accordingly think about their expansion strategy. What can be done to accommodate that many customers? Okay. So here we will take few examples. We will take example of an airline company which wants to predict the increase in the customers or decrease in the customers in the upcoming months. That's one. And second is the car price prediction, like based on the time how the car's prices are getting changed, increase or decrease. Not the car price, rather it's the car sales, sorry. So whether the car sale is going to increase or decrease, because price is a regression problem, like predicting the car sales is a forecasting problem. Okay. And here we will use this package because sklearn internally does not have time series packages or sub packages. We will use a stats model to do that. Okay. So stats model package, which is a statistics plus modeling, इसी से sklearn निकला है actually. This is the parent of that. So we will use a stats model to do the feature engineering or the pre-processing of the time series data and then the forecasting. Okay. So here what I'm trying to do is I'm reading the airline passengers data, guys, and this is how the data looks like. If you look at, there are only two columns in the data, year and passengers. So year on year, whether there is increase in passengers or decrease in passengers, that's what I want to see. But the index column here is 0, 1, 2, 3, right? So this data is still not a time series data. Remember, for time series data, the index should be time, not the numbers. So ultimately this column I need to move here. I need to convert the time column into index column. So I'll use this function, which we will do later, maybe tomorrow or day after. So we will set the year column as an index column, and that's where the thing is done. So let me just do this off. So I'm just reading in the passenger data. So now if you look how the data is changed, right? I have converted year into the index by df.index passing on that column. So now this is the time series data. First of all, remember, दो कॉलम है आपके पास, एक ईयर एक पैसेंजर, वो टाइम सीरीज डेटा नहीं है. जो भी आपका टाइम वाला पार्ट कॉलम है वो इंडेक्स होना चाहिए, तभी वो टाइम सीरीज डेटा होगा. So first of all, you should be clear about time series data. Now once we have time series data, then we can check whether there is any null or not, because definitely if there are any nulls in this, we should also handle that. So there is no null. This is how you check earlier also, it's fine. And then we will do a plot. Now what this plot is of the passengers with respect to time. So definitely time should be in the sorted order. This is already sorted, otherwise you should have sorted it. And this is the passengers, and I'm plotting this data. So when I plot this data, it will graphically, okay. Okay. So when I plot this data, it is graphically showing me the trend. Okay. So now there are some technology words, the important jargons, tech jargons we'll talk about. So first one is, guys, known as trend. Okay. In time series data, we look for trend. We look for seasonality. Okay. Seasons, like you have seasonality. And then we talk about cyclicity, cyclic behavior, cyclic. Okay. So trend, seasons, and cycles are three important words here. So Very good, Vipul. Noise is also the fourth word, but yeah, I'm not talking about that. So there are four things as such, but you are correct, Vipul. It's trend, seasonality, cyclicity, and the noise. Absolutely. But I'm talking about trend. So if you guys look at this data, we can see an upward trend. There can be a downward trend, but here the sales are increasing or the passengers are increasing year on year, right? So the index column automatically came here, right? So this is the trend. Then what is seasonality is within a year, if this is an year, do I see a pattern which is repeating like this, like this, like this? This is like a pattern, right? Where in a particular year, in particular months, the sale is going very high. And it is happening every time in the middle months. So that means there is something, for example, some festive season due to which my sales increases, okay? So that is seasonality. Can anyone tell me what is cyclicity? Any idea? Because as seasons repeat itself, cyclicity is also the events which repeat itself, like my sales going high. So that's what cyclicity and seasonality are both the repetition of a pattern. But what is the difference between the two? So see, the difference is seasonality happens always at the regular interval. And more importantly, it's within a year. Like एक तो वो चीज हो रही है लेकिन हर साल हो रही है और उसी महीने में हो रही है. फॉर एग्जाम्पल अभी अक्टूबर नवंबर में दिवाली है, सेल्स आर गोइंग हाई, ओके. या कोई वेकेशन पीरियड आता है अप्रैल मई में, द फ्लाइट बुकिंग्स गो हाई, होटल बुकिंग्स गो हाई, राइट? So it's happening every year and during that particular time of the year. That's seasonality. Cyclicity is also something which repeats itself, but after a longer duration. Means maybe every 2 years, every 3 years, every 6 years, sometimes maybe after 9 years, sometimes maybe after 10 years, like recession. Recession is there to come every, say, 10 to 15 years. It came in 2008, it came somewhat in 2018, but didn't came that much. But now because of COVID, it's there in 2020. But COVID is a different thing, we should not relate it to. But definitely recession is something which comes after say 10 years or 12 years. So first of all it comes, but it may be thoda aage piche ho sakta hai 1-2 saal ka, and it's a very longer duration, right? So it's a cyclicity. Okay. COVID ideally is not seasonality or cyclicity. COVID is COVID is a noise, I would say, because COVID is a one-off situation where suddenly things behaved abruptly. Either your sales went very high, if it's medicines, sales went very high, like masks and all. Or if it's a travel industry, sales went completely down. It's like crashed. So it's like a noise or a pattern which will occur very less frequently. So COVID and these things cannot be like cyclicity. Definitely pandemics happens, but pandemics so far, because of humans' thought process, their bias, they don't consider this as a cyclicity as such. But yeah, we consider that as a noise because of psychology. But yeah, that you're right, Rahul. It's actually a pattern. Somewhat or other things, some pandemics occurs. But it's just a human psychology. They consider it like a noise. Yeah. So by looking at this graph, you can definitely see that in every year there are some spikes, and that too during a particular time or the month. So there is trend, there is seasonality, both in this data. So this is a time series data with time and seasonality. So this kind of data is known as non-stationary data, non-stationary time series. So this is a non-stationary time series. So before we implement the time series forecasting, we have to convert this non-stationary time series into stationary time series, where instead of going like this, it will be something like a flat line. So we apply some transformations, you can say feature engineering, to convert a non-stationary time series into stationary time series before we apply the machine learning models. Okay, so making it stationary means you remove trend, you remove seasonality from the data, and try to bring it somewhat like this. Yeah. So after too many transformations, this is what I would say is a somewhat stationary time series, where I have removed the trend, so it's not going like this. I have removed the seasonality, so it's going like this, somewhat like this. Okay. Yeah. So somewhat only the noise is left. So I've removed everything else, so that the models, the time series models, they understand the stationary time series better before we start to implement the models. Okay. So our purpose when we will do time series is first to see whether there is a trend or seasonality. If yes, how to remove it to reach to this point. And once this is done and we are satisfied, we will have we have multiple statistical tests. Okay. So graphically we cannot rely, right? Graph तो मुझे बता रहा है वो stationary हो गई. But is there any test for stationarity? So there are certain statistical tests. Okay. So to check this stationarity, whether a time series is stationary or not, we have some things known as ACF and PACF plots. We will see that. We will do rolling statistics. So what is rolling statistics? We will do this statistical test, which is Dickey-Fuller test or augmented Dickey-Fuller test. There are other tests, KPSS test and PP test, but we will only focus on this. So we will plot ACF, PACF, rolling stats, and Dickey-Fuller test. So Dickey-Fuller test is the actually hypothesis test, like you have T test and Z test, right? So here we have Dickey-Fuller test. The above two are actually the graphical test, the graphical plots. So we will do this, and these three are actually the hypothesis testing. So we will do the augmented Dickey-Fuller test. We build a hypothesis, and जब तक वो hypothesis true नहीं हो जा, मतलब p value 0.05005 या 0.05 नहीं हो जाती, हम उसको stationary करते रहेंगे time series को. And once we get the stationary time series as per the Dickey-Fuller test and all, we will apply our models, which is the ARMA RIMA models. So we will do those models later, but yeah, so once we are done, then we will simply be implementing the models, which is auto regression model, moving average, the sum of the two, which is ARMA. ARMA is like auto regression and moving average. So this is one model, this is another model. Both of these combined together gives you ARMA model. Okay. Then there is this ARMX, where what is this X is, अभी तक हम सिर्फ दो ही फीचर्स की बात कर रहे थे, टाइम एंड मतलब टारगेट, बट देयर कैन बी other features like age, or location, means these are known as exogenous variables in time series. So any column or feature other than the time and the target are the exogenous features. So it's like multiple features. If you have, you use Armex, not ARMA. Similarly, we have ARIMA, SERIMA, VARIMA, exponential smoothing, all these. Okay, so these are the actual forecasting models that we will do. Yeah. So here, if you see the red part is actually the forecasted line. The red part, the blue is the known, and the red is what we have forecasted, like how the future predictions will happen. Okay. We'll see all these things, but yeah. So we will use stats models, guys, entirely for this, but Facebook has given another model known as profit model. So that's a package actually, which do nothing but same things, but it's a separate package given by Facebook known as profit. Okay. And there is one more package which is known as auto ARIMA. So we will talk about three packages. One is a stats model. So 99% of our work will be done using stats model. Just there is one auto ARIMA, like automatically doing the time series using pyramid package. There is a pyramid package. So pyramid and auto ARIMA, and then Facebook's profit. These are the things. So we will talk about these tomorrow, not today, but I just wanted to give you a brief so that you have basic idea that time series analysis is to look whether the data is time series or not, whether there are any exogenous features like other than those two, and whether the time series time column is index or not, whether there is trend or seasonality, how to remove it, like making a non-stationary into stationary, and finally doing the predictions using the ARMA, AR, MA models, ARIMA, VARIMA models, or maybe the Google's profit model and all. Or maybe auto ARIMA. So all these things are there, but yeah, you should have a good understanding now what time series is, and we will do this. So you can remove the trend, then you remove the seasonality, and then whatever is left over is what you will work with. So you normally remove trends and seasonality, you don't worry about the other things. So there is a decomposition that we will talk about. So there is a decomposition function that is there, Nishtha. Using that decomposition, we decomposes the given time series into its inherent components. So what are the components of a time series? Trend. So this is a trend line, right? So this is the original time series. We took out the trend. We took out the seasonality. So whatever is left is actually the residual. And actually this is what we will use for our predictions. Okay. We'll just cut off these two. And when we get the prediction out, so when we get the prediction from the model, we have to add back the seasonality and trend, because these things were taken out just to implement the model. But once you have the output, you have to add back the seasonality and trend, otherwise your predictions will be wrong, right? So remember that. So after implementing all these models, ARIMA, FARIMA, whatever, we add back the trends and seasonality which were taken out to give you the exact correct value that you need to predict. Otherwise your scales will be different. Consider it like that. You cut out these and say your scales from 100, it came out in the scale of 10, in general if you talk about. So your predictions will be in the scale of 10 only, right? So you have to add back the importance or the weight of these features, right? So as to go back to the scale of hundreds, otherwise your predictions will be wrong. Okay. Yeah, Nishtha, that can be done. We can store these in separate variables, definitely. So we will be interested only in this final thing, the residual part for our predictions. Whatever is remaining after removing all this, okay? Read about these things, guys. So tomorrow we will do the XGBoost and CAT boost and the light GBM, and then if time permits, we will start this time series. So Rahul, this file is there. So what I have done, Rahul, if you go into notebooks, I have created this. 1 second. I've created these folders actually for Kaggle, naive Bayes, time series, and unsupervised learning, right? So Rahul, you can go in time series, and there you can see all these files. Okay, the time series analysis files. You can read through them. Okay. This is a neural network, so it's not for you. You guys can ignore this. This is for deep learning through time series, but leave it. You can go through the other files. The data files are there and the notebooks are there. So for initial understanding, go through this. Then you or you can go through or any of these three. You can start with this or this, whatever. Okay, guys, I think I'm done for the day. Let's connect tomorrow. So please revise the boosting because it's confusing. Specifically GBM, how it works for the regression and classification. You can go through the YouTube videos also. A lot of YouTube videos are there. Okay, so thanks guys. Thanks a lot.